Alright, it's going. I don't know if one of you guys want to take lead this week. I really didn't understand a lot of the material, or like any of the material. So, if one of you guys want to take the lead, that'd be awesome.
Start with the number 1, and then I'll do 2, 3, and 4. I just don't like starting.
Okay. Lesson 4, right?
Yeah.
Yes.
Okay, so for number 1, I did the heterozygous parent, and I got CWX capital S8 over capital C capital WX lowercase s8. Okay, are you guys good with that?
Yeah, I'm good with that, but I think he didn't. How did you do it since he didn't understand?
Yeah, I'm like completely lost. So I don't know, even if we just go through one, like in detail, I think I should be able to get the other ones, but I'm just really confused on how to even start these.
If she does 1, I can do 2 for sure.
Okay, so when it's asking for the heterozygous parent, heterozygous is, so it really doesn't matter which parent is female and which is male, okay?
Uh-huh.
So heterozygous, you have 2 alleles. You have capital C and lowercase c. So one goes to the mother and one goes to the father. But when it's asking for hetero, you see how there's capital WX and lowercase WX?
Uh-huh.
Those have to be split up. So I just put lowercase c and lowercase WX and put it on top. And then the capital S and the lowercase h and put it on top of that.
Okay.
And then I don't really gene order. I think you kind of just pick that on your own, don't you?
Well, from the sound of it, there was like some way to like calculate it, but that's kind of the point that I got super lost in.
I thought you didn't calculate until like part C and D.
I don't know.
Nika, did you just want to explain too? Because it's basically the same thing.
I couldn't hear you. I'm sorry.
You just want to explain number 2 because it's the same thing.
Okay. Alrighty. So which one did you want me to explain? Number 2? You want me to just go through C and D since you already did A and B?
Well,
Okay.
also B, how to determine the gene order.
Okay. So the way that I did this, I think it's easier for me to start with C just because one of the videos that she put up on the link, it's basically like you match the bigger with the other bigger one. So for example, I matched the 151 smooth, tall, normal to 155 peachy, drift, and opalate. And then I added those 2 together, and then I got the second 2 that was closest to each other, which was the 33 smooth, tall, and the 33 and the 29. So I added those 2 together, and then I got the next one, which was the 12 and the 11, and then I added those two together, and then I got the smallest. So far, so good?
So you took the two largest, the two next largest, and the two next largest, and you added those together to themselves?
No, well,
So like the 151 plus the 155?
yeah.
Okay.
And then the 33 plus the 29,
Right.
and then the 11 plus the 12,
Mm-hmm.
and then the 2 plus the 0.
Mm-hmm.
So this is for number C. So it asks us, like, the formula states that for the length genes that you have to have, like, the formula for distance between is basically number of recombination over the total times 100. And the reason why we're using 100 because 100%, in order for you to calculate a percentage, you have to use 100%.
Right.
So far, so good?
Yep.
And we know that every time we use the distance between the gene, we don't start with the largest one. We start with the second largest.
Uh-huh.
And that goes for all those problems. For this whole, we start with the second largest, and then with the second largest plus 2. And then the one thing I forgot to mention is that from the result that what we're finding in F2, you have to take the whole number and then add it up, and then you'll get a total of 393.
So what did you add to get 293?
No, you get 393. You add the whole F2 results.
Okay.
You add 151, 33, 11, 2, 155, 29, 12,
Okay.
and 0. So far, so good?
Uh-huh.
And then so basically the total, since the equation is a number of recombination over the total, which is 393. And then right? Tell me to slow down, or if you don't understand, I'll slow down.
No.
Sorry, I get like really nervous and just start talking and don't know when to stop.
You're good?
Okay, so basically we do 62 plus 2 over 393.
Say the top numbers again.
The number of recombination is 62. The second largest plus 2.
The second largest plus 2?
Yeah.
Okay, so your second largest was 33 plus 29, and then plus 22, or plus 2?
Yeah.
Okay.
So that equals 64 over 393.
Okay.
So once we get that, we divide it like we do the thingy. Sorry if I say thingy. We basically divide 64 divided by 393, and then we'll get 0.1628.
Uh-huh.
Times 100%.
Uh-huh.
And you can go ahead and do that calculation yourself, and then tell me what you get, just so you can do like the process instead of like me just talking.
So I think you said 0.2918, right? Is that what you said the fraction was?
Hold on 1 second. I'm so sorry. Hold on.
Hey.
Yeah, I'm sorry, John. Sorry about that.
So it's 16.28%.
16.28.
Mm-hmm.
At 16.28. And we know that, like, with chemistry 1, we learned that in significant digits, based on the numbers that we have, based on the numbers that we were given, the largest significant digit that we're supposed to have is 3. So we just keep 3 significant digits.
Okay.
So it's 16.3. You would round the 3 because of the 8.
Okay.
So that's good for that one. And then that's just, say for example, that's just part A. The second part you would do is the second to smallest one, which is 12 plus 11.
Okay. And you just do the same thing for that one.
Yeah, 12 plus 11, which is 23 plus 2. And then
Corbin.
divide,
Come here.
and then
Come
you
here.
divide it by 393.
Do you want Cheerios? Uh-huh.
So I can look at the
And you get your new percentage. And so you just do that for each of the percents.
Yeah, so basically with that one, you'll get, no, like, let me just explain that process to you, just because, like, and the rest of them, you would have to know this process in order for you to calculate each and every single one of those problems coming up. Are you here?
Yep, I'm still listening.
Okay. So basically, we got 25 over 393, right?
Mm-hmm.
And then we do that division. If you want to go ahead and do that division yourself. So we get 0.0636, and we times it by 100. Which is 6.36.
Uh-huh.
And again, we know that with significant digits, we just round up to 6.4.
Uh-huh.
So that's that for that, right? So far we got, for the first part, we got 16.3. Now for the second part, we have 6.4.
Right.
Okay, perfect. Okay, now we know. I'm not really sure, like, after here, maybe you could, like, help me out with the wording. Like, I don't want to talk about, I just don't know, like, so, for John, basically for, like, T, for heterozygous T, well, T slash T, there was this little mapping on the slide that basically show you how to order them, to which one is closer to the other one.
Uh-huh. So the smaller percent means that they're closer to each other.
No,
Or
not
is that what you're talking about?
No, not necessarily at all.
Okay.
Ashley,
What was that?
do you want to explain that part from the length to the length? Because I think I'm talking too much.
What part?
Do you know the part from, like, from T slash T, and then you take it from the T slash T to the other end, which is N slash N?
No, this is the part that I needed you to explain. I got the first. I know A and B. I don't understand C.
Oh, okay, you didn't understand that.
Yeah.
I don't know how to explain it, basically, like.
Just try, and maybe I'll help you out.
Okay, so basically with the T slash T, basically you take the different trades, and so for example, I started with trade 2, which is the T dominant and then the T recessive, and then I follow, like, I had a long line. I don't know why I'm having a hard time, but hold on, I'll put my camera on and maybe you can see this while I'm explaining it, so it kind of makes a little sense. Okay. I don't know if you can see my face. Can you see this? No?
No, it's really blurry.
Okay, I'll try anyway. Well, basically, you start with the T/T, and I put the T/T. And then I put a dash, basically meaning that the 6.4 is closer to trait 1. You got that?
Yeah.
So it's like trait 2 is closer to trait 1. So since it's closer to trait 1, I put 6.4 MU.
So how do you determine? Go ahead.
Where did you get 6.4?
That's the whole calculation I just explained.
Oh yeah. Okay. No, I got it. I'm sorry.
Okay, I'm like, oh no.
No, I thought you were getting it from like the word problem or something.
No.
Okay, I get it.
So how do you determine, though you were talking about like gene 1 and gene 2, like how do you determine
No, I'm
which
talking
gene
about
you're
trait
calling
2.
gene 1 and
How do I determine gene 1 and gene 2?
like yeah, you're saying it's like 6.4 from gene 1 to gene 2, like how are you just
No, that's
you
from the
haven't
trait.
specified yet.
No, that's from the trait on the top of the paper. You see how it says trait T dominant? I'm basically saying T/T. The T dominant / the T recessive.
Okay. Okay, so you're saying from okay.
So then 16.3 goes in between S and N.
Right.
Okay, so then what's the formula for inferent?
What's the formula for what? I'm sorry.
Interferent?
It's I equal 1 minus the. It's like 1 minus the. I wouldn't say constant, but it's like 1 minus the problem that you get. The numbers that you get. Hold on, I could find out the exact word for you, the exact wording, because I have a problem with wording sometimes. But I could go ahead and explain that one too. I'm sorry if I'm like confusing you guys though. Okay, so the formula for interference is basically 1 minus the total amount that you get after calculating the value. So do you want me to explain that one, and then I'll show you the value that I'm talking about, since I don't know the exact word.
For the interference, I got 0.51.
Yeah, it's 0.51. Do you want to explain to John like how you got the whole process and stuff?
John, do you not? You just plug it into the formula.
Okay. I think I can handle that.
Do you want me to help you with the formula, John?
No, I can just look it up.
I think the hardest part is finding the numbers to construct the map.
Yeah, it starts with a C.
So I think I can understand the numbers themselves and like how to, but when it comes to gene order, that's where I'm confused still. Like, how do you know which gene comes first? Like, I understand like the, no, I'm not even going to say that. I have no idea how you calculate gene order.
Okay.
Or you figure out gene order because they're not really calculating.
Actually, did you understand that one? Maybe you can like explain it and I can.
Sorry, I can't hear you.
I said, do you wanna like explain how to calculate the order? Maybe you can like explain whatever you mentioned.
I think you should just go through our answer. John, did you do any of the problems?
No, I'm just was completely lost.
Oh, you didn't submit 2 and 3 last night?
No, I couldn't figure them out.
Okay. Well, do you want to try number 3 and then...
Yeah, we can just do that. I think I have a good jump on it, and I still need to watch the videos she just posted today.
Oh, that will help you a lot.
So I haven't had a chance today to look at them because I've been in class all day. But so you guys, if you guys want to go look over the answers, and then I'll.
No, I can like you alone with calculating the gene order.
Well, I think just for sake of time, because I know Ashley has to go, and I still just need to be able to try to work through them,
If
and
you
then
want
maybe
to,
I can.
help you.
Well, if I have questions after the video, I can always contact one of you again to. Hey, be nice.
Well, maybe I think what would really help. Nika, do you want to explain C again, how to find the numbers?
Yeah.
Because that will really, that's the hardest part.
John, I can do that. I can explain it like 50 times if you want me to. I just don't want to keep talking so much.
I have how to get to the numbers though. Like I understand the percentages.
Okay.
I'm just not sure how those tie into the order, or how to figure the order from that, or however you do it.
I can probably like. Okay, well I can probably like explain alone. Maybe actually you can probably take it away from that. But I'm not sure if I'll be too good with that. Okay, so basically the first thing that you do when you're calculating the gene order is like you have to identify the parental classes and the double classes. And you have to like be careful not to like order it based on the way that it's written. Like you see how on top the trait 1, 2, and 3 is like ST.
Right. And so the parental are the most common ones. So the smooth, tall, normal, and the peachy dwarf oblate.
Right.
So I have that part.
Okay. And I don't know, like I know what I'm talking about, but I'm not doing anything. Actually, do you want to try to giving it a shot?
Like what?
Do you want to try giving it a shot?
How I usually just I start with the middle trait that's given in the word problem.
Uh-huh.
And then I go to the first and then the last, and then you just plug in the numbers, but you get, like, for 3, I put 20 MU and then 13 MU. I don't know, does it matter how many, like, how long the line is?
Yeah, I think it matters because the line has to show like the distance, how far apart they are, how close and how far away they are, like the MU. Okay, so John, basically, like the things you have to know in order to calculate is that the only which has like recombination in the double cross will always be like the middle one because of the between the first two genes, then cross them back. I don't want to confuse you more. Maybe just ask the professor.
Hey, you okay? Get some Cheerios?
I don't know. So, should we go to D or no?
Yeah.
I think I have D2 because you just take the numbers you already have and you plug it in, right?
Not necessarily. There's like a lot of calculation before you do that.
Okay.
Do you want to go through the process of the calculation? How to calculate the constants or no?
Yeah, could you run through it real fast?
Okay.
Make sure
So-
I did it right.
So basically, remember how we got 16.3 and then 16.4 for the MUs from letter C? So we do 6.4 over 100.
Uh-huh.
The reason why it's over 100 because it's 100%.
Uh-huh.
And then we do, so whatever we do for that one, so basically we do 6.4 over 100, calculate that one, and then we do 16.3 over 100, calculate that one. And then take the first one times the second one, which is 0.64, I think. No, 0.064. Are you doing the calculation with me, John?
Yep.
So 6.4 divided by 100. Which is 0.064. And then
Corbin.
16.3 divided by 100, which is 0.0.
Hey.
So it's like 0.163. Is that what you got?
0.00030666765. Unrounded.
Sorry, I couldn't hear what you got.
Hey, go play. I'm sorry, 1 second.
Alright.
I got 0.000668.
No. Can you repeat what you calculated? I don't think we got the same thing.
So it's 0.064 times 0.163. Right?
Okay.
Hey, Corbin.
Yeah, 0.064
times 0.163.
Yeah, and what did you get?
Let me try it again.
Alrighty.
So I got 0.0104.
Yeah.
Where's your monkey? Go get monkey. Monkey.
Okay, that's good. So once you get that part, remember that once you get that part, you multiply it by the
Where's your monkey? Sorry, what was that?
multiply it by the total.
Okay. Corbin, hey,
Are you here with that actually?
Corbin, you don't want more. Sorry, give me a second. My son's in meltdown mode. Let me get him something to entertain him. Hey.
But actually, are you here with us?
Yeah, I'm good.
Did you get that part so far or no?
Yeah.
All right, I'm back. Hello?
Yeah.
I'm back.
All right. So did you get
Corbin. Did I get the what? So what was I dividing the 0.0104 by?
Yeah, so basically we said you do 6.4 divided by 100, and then you do 16.3 divided by 100. Those two values that you get, you multiply them by each other. After you multiply those two values together, you multiply by the total for F2 results. And you should get 4.099776 for that part. And then we know that the formula is like 0x2. It's like the bottom total with the smallest number, with the smallest result from F2. And we know that the smallest result from F2, when we added 2, the smallest result that we had was the 0 smooth, drift, and obsolete, and 2 peachy, tall, and normal. So we did the 2 plus the 0. Remember that, John?
I think I'm gonna have to go. My son is in complete meltdown, and I can't hold him and write. So I'll just leave it running, and then come back and stop it, okay?
Okay, no
And that way you
problem.
guys can finish up.
Okay.
All right, but thank you so much for trying to help. I'll probably contact you if I need more
Yeah,
help
you can
later
just
in the week.
no problem.
All right. See ya.
Yeah.
Bye.
So
Okay.
you get that part or no?
Yeah, I'm with you.
So you basically got that, how to calculate that, right?
Yeah. For number 4, for the interference, did you get 0.498?
Hold on, let me change to my number 4 because I was like still on number 2 right now. Yeah.
Okay. This one I was kind of confused on finding the heterozygous parent just because they're all lowercase letters.
I was kind of confused on that one too, but I can start and tell you what I got, but I'm not sure how effective my answer would be.
Okay. I got y plus c plus b over y b c plus.
So you basically just did it with the yeah, okay. That's what I thought too. Basically the range that it came in.
Yeah.
I'm not really sure if that's the pattern for it, but that's the one I realized too, that with the arrangement and the heterozygous, it's basically the way that it's shown to you, like the way that the question is presented. but I'm not sure if that's necessarily true.
That's what I got too.
Okay.
I never know how long to make the line. You know what I mean?
Okay. Yeah. Like as for me, the way that I usually make my line is basically like, say for example, this is just like a really small, simple example. If we had 1, 2, and 4. No, say for example we had 4, 2, and 1. I would put the line from 4 to 2 longer.
Oh, so it doesn't actually matter. You just have to make them longer if they're longer.
Right, just the way that I came across from it, but
Okay.
actually let me pull out my notes. I wrote it down. But yeah, that's the way I came across from it, yeah. For sure.
Okay. I'm good if you're good.
Yeah, I'm fine actually.
Yeah, I have to start packing.
Alrighty, if you wouldn't mind like texting him, telling him he can shut it off now.
Okay. I'll text him.
Alrighty, thank you.
Alright, bye, Nita.
Alrighty, bye bye.